So this one is used again, useful to test a composite null hypothesis against a composite alternative hypothesis. Okay, composite null hypothesis against a composite alternative hypothesis. Ataupun you can either one lah ya. Either both of the hypothesis H0, H1 can be composite or salah satunya. Okay, that's mean your null is simple hypothesis but your alternative is composite. Okay. So suppose that the null hypothesis, okay, the null hypothesis specifies that theta ni let's say your unknown parameter, maybe a vector, lies in a particular set of possible values. So let's say we write down your null hypothesis, theta you punya parameter belong to, ini kita panggil sebagai small omega small omega, and then the alternative hypothesis specify that theta in your alternative, which is your H1, theta lies in another set of possible values which is omega 1, okay, which does not overlap. So that's mean kita ada null theta belong to omega, small omega, alternative theta belong to small omega 1. Okay, so omega dia ni lah sample space kamu, we have small omega union with alternative punya omega, dia punya set dia. Okay, so either or both of the hypothesis H0 and H1 can be composite. Okay, salah satu ataupun both can be composite. Okay, that is for likelihood ratio test. Okay, so likelihood ratio test, so again when we mention about likelihood relate to likelihood function yang kamu buat join PDF of x1, x2, xn, the same approach. Okay, but now we will have a maximum. Okay, ini tanda L small omega head. Okay, L small omega head be the maximum. Okay, maximum value of the likelihood function for all theta belong to small omega. Okay, so that is your L omega head name, maximum theta belong to small omega, which is your H0 tadi. Okay, so L omega head represent the best explanation for all the observed data for all theta belong to omega. Okay, we write down L omega head. Okay, yang besarnya, capital. So we have maximum L theta belong to omega, which is your theta belong to omega is small omega union with alternative omega. Okay, so again we will take the ratio. If likelihood for small omega head is equal to large omega head, then the best explanation for the observed data can be found inside omega, and we should not reject the null hypothesis. Okay. However, if your small likelihood function for small omega head is less than, so the best explanation for the observed data could be found inside the alternative omega, and we should consider rejecting H0. Okay, so this one define your likelihood ratio test. Kita ambil likelihood function for small omega head divide by likelihood function for large omega head. Okay, which is large omega head, that's mean value that concern with your null hypothesis and your alternative. Yang small omega head tu only concern on your null hypothesis. Tapi kita ambil the maximum likelihood function. Okay, theta head ni lah. So that is your likelihood ratio test. Dia punya statement, dia punya definition. Okay, we will refer to this one. Apa maksud likelihood ratio statistic? So maksudnya this one let's say kita pakai simbol apa saya pun tak sure nak bagi apa this one. Triangle ni lah triangle this one. So you have likelihood small omega head over likelihood for large omega head. So you take the maximum value of your likelihood function for theta belong to small omega, which is your null hypothesis, divide by maximum of your likelihood function L theta, but theta belong to large omega, which is all the possible values in your data set. So that is your likelihood ratio statistic. Okay, kita akan the same approach macam Neyman Pearson, tapi dia depends pada maximum likelihood function. Okay, maximum likelihood function. Okay, so a likelihood ratio test employs your null hypothesis against your alternative. Okay, so this one as your test statistic, and we will determine the rejection region C is determined by your triangle here is less than or equals to some value of K. Dia punya approach sama. Anything must be less than or equals to K. Okay, kamu ambil dia punya likelihood ratio and then setkan less than or equals to K. So clearly, if your value is between 0 and 1, a value of your likelihood ratio statistic close to 0 indicates that the likelihood of the sample is much smaller under H0 than it is under H1. Sebab kita ambil ratio kalau close to 0, that means dia much smaller under H0 compared to H1. Therefore, the data suggests favoring H1 over H0. But the actual value of K is sufficient so that alpha achieve the desired value. Okay, kita akan check kita punya nilai K tu bergantung pada nilai alpha. Okay. Bergantung pada nilai alpha daripada soalan yang diberi. Okay, cuma dia punya likelihood ratio statistik tu, the value is normally between 0 and also 1. Dia punya ratio dia. So kalau close to 0, that means most probably we will reject our null hypothesis. Yeah. So that is the properties. Small value of the ratio would lead to rejection of H0. A value of the ratio close to 1 would support the null hypothesis. Okay, so that is the properties. So ini kita tengok dia punya procedure, how you want to construct the likelihood ratio statistic. Okay, procedure of likelihood ratio test. Okay, so first we will find the largest value of the likelihood for any theta in omega, in small omega. So maksudnya, find the largest value of the likelihood in your null hypothesis. So this is done by finding the maximum likelihood estimator. So ini relate balik pada konsep MLE. MLE in our first chapter, chapter 1, restricted to values within your omega, apa yang disebutkan dalam null hypothesis. And by substituting the value of theta back into the likelihood function. Okay, kita solve finding the MLE, lepas tu kita masukkan balik, substitute back in your likelihood function. So this will result in a value of the likelihood function that we call as L small omega. Okay, so next step, find pula the largest value of the likelihood for any theta in omega. So we write down likelihood L omega, and then the third step, we take the ratio. We take the ratio, kita simbolkan head pakai head estimated value. So L small omega head divided by L omega head. So this ratio is called as likelihood ratio test statistic. Okay, and then kita solve, kita akan reject kita punya likelihood ratio test statistic if this one is normally less than or equals to K lah. Less than or equals to K. So this one is less than or equals to K. So the test procedure call for rejecting the null hypothesis H0 when the value of this ratio is small, say whenever your likelihood ratio test statistic is less than or equals to K. So the likelihood ratio principle require rejecting H0 when L omega is much larger than L small omega, which would indicate that the sample data are more compatible with the alternative hypothesis compared with the null hypothesis. Usually the constant K here would be selected to give a specific value of alpha, which is the probability of type 1 error. Okay? So if you have your alpha, the value for alpha, you can find your value for K in your likelihood ratio statistic.